Take it away, Ryan.
All right, thanks. Can you guys, I think I shared my screen. Can you guys see the slides?
No.
No. Let me try this again. I'll actually know where my Zoom. Oh, I think I hit leave meeting by accident. Bye. Okay, how about now?
Yep. We can see your web browser.
Slides.
There we go.
Cool. Yep. All right. So yeah, I'm going to give you some tips and also just kind of show you some of the tools that exist to help with putting a GBT proposal together. Some of you may have already been on GBT proposals. Hopefully you'll have a better idea of how to write some on your own. I should say that most of these slides were taken and adapted from Tony Minter, who has given this talk before as well. So I don't have a ton of slides, but I am going to want to show some of the proposal submission tool things a little bit in kind of real time. So we'll see how that goes. But I will go through a few things and kind of try and flow through the logical order of how you might start with a proposal all the way up through submission. So we will put out a call for proposals twice a year. The proposal deadlines are February 1st and August 1st, and the call for proposals typically goes out about a month or maybe a little bit before those deadlines. The call for proposals typically has a lot of the same information from semester to semester, but it will have some information that will change from semester to semester. This is particularly true for instrument and receiver availability. So we are not able to install every single receiver that we could install on the telescope at any given time, just because there's not enough space. We can do receiver changes throughout the semester, and that will happen in response to the kind of scientific demand, but there are certain semesters where a certain receiver may not be available. So make sure that you look at the proposal call to know what the plan is ahead of time for particular instruments. And if you have any questions, just reach out to Tony Minter or to anyone else at the observatory who you've contacted prior. The proposal call will also contain information about the overall capabilities of the telescope, a lot of stuff that you've already heard now, so you should be reasonably familiar with, but it's always good to refresh yourself on those things. The proposals are judged competitively by an external panel and then also undergo a technical review. So you need to make a pitch to the reviewers effectively and sell your idea and convince them that it is worth doing in the face of other potential projects. So as you are writing your proposal, ask yourself, why is this worth doing? Think about someone who is not involved in your science necessarily. They may be familiar with your science area, but they may not be experts in your particular discipline. So think about why they might be interested in the science that you're doing. If you are doing something novel, call that out. If you are doing something which has been done before, think about what it is you're going to contribute, which is unique this time. So if you're observing an object or a set of objects that have been observed many times in the past, are you covering a new frequency range? Are you going deeper in sensitivity? Are you using finer spectral resolution to get a better velocity resolution? Are you looking at unique properties of the pulsar, maybe like single pulse properties or something like that? One of the big things is to think about what makes the GBT necessary. And if it's the only telescope that can do what you want to do as well as you need to do it, that's especially good to call out. The GBT has some unique capabilities that other telescopes don't. There are other single dish telescopes with overlapping frequency range that also have similar capabilities. In some cases may even be more sensitive, telescopes like Arecibo, for example. So think about why the GBT is the right telescope, and think very carefully about the science requirements. You don't want to go in asking for more time than you really need. We will check sensitivity calculations and we will flag proposals that are asking for more time than they need to meet their scientific goals. In the TAC, the Time Allocation Committee can go in and adjust the time request if they feel that's necessary. You don't want to sell yourself short, but you also want to make yourself competitive, and part of that is not requesting more resources than are necessary. So there are a few different proposal categories. I've broken them down here into both regular and large to start off with. The definitions for these are frequency dependent, and this is because we have fewer hours out of the year that are available for high frequency projects. And so the threshold for what is considered a large project and requires extra justification is a little bit more stringent for those higher frequency projects. And I'm saying higher frequency, it's really more about what requires the best weather, though, which is related to, but not a one-to-one relationship with frequency. At any rate, in the 0.3 to 8 gigahertz range, in Tony's slides had 0 to 8 gigahertz. I just put the lower range of the telescope. If we ever did go to lower frequencies, we could drop that number. But basically, below 8 gigahertz, you can observe pretty much any weather that we get outside of like very high winds or heavy snow or something like that when the structure of the telescope needs to be considered. And for that, a regular proposal is less than 400 hours total time requests and less than or equal to 1 year. So you can propose for a project to be active for 1 year, 2 semesters, if you're submitting a regular proposal. 8 to 18 gigahertz, considered good weather, that's less than 200 hours or less than equal to 1 year. Between 18 and 27.5 gigahertz, where there's a water line and we need very dry conditions, as well as above 50 gigahertz, then that's considered excellent weather conditions, and that requires less than, or the threshold there is less than 100 hours. And I don't think I actually put this on here, but between like 27.5 and about 39 gigahertz, where there's up to about the oxygen absorption line range. That's also considered good weather, and so that falls into the 200-hour category. If you're doing a fixed time or monitoring project, that doesn't matter what kind of weather you need, the definition is 200 hours there. So an example of a fixed time project is one that requires observations on a very specific date. What might that include? For example, if you want to observe a particular source when it is an eclipse or near eclipse, or perhaps in conjunction with the Earth, or if you're doing a VLBI project where you need to observe at certain points of the year to, say, measure parallax, that would be considered fixed time. And the requirements there are a little bit more stringent because the telescope is usually scheduled semi-dynamically, where we take advantage of weather forecasts to try and schedule the most appropriate projects for given weather conditions. And when we have fixed time projects, they observe no matter what the weather is, and so it just can potentially take time away from projects in good weather conditions that might need it. And so the requirements are a little bit more stringent. A large project, I'm not going to go through all the numbers again, but they're basically greater than the numbers I put up above. The difference here between large and regular is not just the number of hours, it's also the type of proposal that you put in. So for a large project, the page threshold for the proposal is higher. It's 10 pages, 4 pages for a regular proposal, but there's also extra information that's required. You need to have a data management plan that's included. You need to present a more detailed plan for how you're going to disseminate your results. They usually include some sort of a public-facing website where you can put scientific data products after the proprietary period has gone up, as well as a few other requirements that are spelled out in the call for proposals. So you're asking for more time, a longer project. The threshold that you need to cross that is a little bit higher, and extra information is required.
Ryan, we have a question about the DDT call that was put out in April.
Yes.
It said that Green Bank would like to invite DDT proposals for low frequency filler time.
Mm-hmm.
And the question is this still in effect?
That's a good question. I've not heard anything about us. So first of all, let me real quick go over what DDT proposals are, and then I'll circle back to that. So there's 2 other types of proposal categories. Triggered proposals are submitted at the normal proposal deadlines, but you don't necessarily know what you're going to observe in advance. So you might say, we want to observe a magnetar when it goes off, but we don't necessarily know when that's going to happen. So you have to include very clear trigger criteria. So you might say when a potential magnetar is detected with Swift or Chandra or something like that, above some certain flux threshold, that is my criteria for triggering. So the trigger criteria must be clear and very well justified. But these are regular proposal lengths. They can run for up to a year. And you're not guaranteed to necessarily get all the time if the triggers are not activated, but that can be useful for transient sources and the like. There's also director's discretionary time. So these can be submitted at any time. There's no restrictions on when to submit director's discretionary time proposals. And there are two types, target of opportunity. So let's say that you didn't, you're sitting around thinking about pulsars all day long, and all of a sudden, people announce the existence of fast radio bursts. And you're like, wow, this is a incredible new thing. And then somebody comes up and they find a new fast radio burst and you want to observe with the GBT. And you didn't submit a trigger proposal. Well, you can submit a target of opportunity proposal instead for some sort of unexpected phenomena. The response time on this is rapid. So we try to schedule these as quickly as possible if they pass scientific review. And the turnaround time can be as short as 48 hours or even less potentially. It kind of depends on what else is going on the telescope and how we can shuffle things around. I will say that if you submit a target of opportunity, it's never a bad idea to send a heads up email to Tony Minter and or Karen O'Neill, just to let them know as soon as you start writing, to keep an eye out for it. And another one to let them know when it is submitted. They should get automatic emails about this. But if you're trying to get a response as quickly as possible, giving people as much advance lead time is a good idea. And then there's also exploratory time proposals. So these are typically for just a small amount of time. And they tend to be intended for like pilot projects. So let's say that we just release a new instrument and it's kind of in commissioning phase and you would like to use it for a small exploratory program to kind of test out what the capabilities are and see how it might be used in a larger project. So you can submit an exploratory time proposal for that. So let me go back to the question then. So you can submit a DET proposal for a low frequency filler project at any time. What this particular call was in reference to is that because of the COVID-19 restrictions, we were not able to do as much of the maintenance on the telescope as we normally would, which included some receiver changes and other things. And so we were looking for proposals that could take advantage of any weather condition with receivers that are always installed on the telescope that might fill some gaps in the schedule that would have emerged because of the change in operations. So we put out that special call, not because you couldn't have submitted a DET request otherwise, but because there were some extenuating circumstances and we wanted to let people know about that and especially encourage them to think about ways that they might take advantage of that. And we were considering larger proposals than we may normally have for a DET project. I haven't heard anything about that being officially rescinded, but I will say that our operations have become more regular. They're still not normal, but we're able to do maintenance and receiver swap outs. And so I think that there is less time available for those types of filler projects. So yeah, if you have a particular idea in mind, if it's a short amount of time, I would say go for it. If it's a large amount of time, I would just reach out to somebody like Tony and see what the current status is, because you don't want to put all the work into a proposal if you know that it's just not going to fly as a DDT. I've also mentioned this filler time. So when you submit a proposal, you can ask for it to be given consideration as a filler project. It will, if it accepted, it will automatically be given a C ranking. And it will basically not be guaranteed any time, but it will be considered for scheduling on the fly if there's gaps in the schedule. Let's say that an instrument misbehaves and we need to fill a gap in the schedule relatively quickly. Or there's just some hole in the schedule which is too short to schedule another project, but not long enough, or sorry, just long enough that you can still do like a simple L-band, let's say H1 survey on the fly. You can submit those types of projects. The bar for getting them accepted is a little bit lower because they kind of help fill out the telescope schedule a little bit. But again, you're not guaranteed to necessarily get all the time. And they're the type of thing that needs to be run on short notice. So something that can be operator run, or that you have a large team of people that can respond quickly if called upon. So just some general tips and advice for proposal writing with GBT. So depending upon the cycle, we get a few hundred proposals each deadline. There are a small number that are obviously really, really good and probably will not have any problem passing muster. There are a few that are obviously poor, but all the others are about, are good. They're perfectly worthy, and it's, you're kind of digging into the details when you distinguish against them. So some tips for making your proposal stand out. So you will, on the cover page, have space to put an abstract. Really think about that abstract. It's limited to 200 words. Get the point across quickly. Get the reviewer interested and let them know what you want to do right up front. Provide enough introduction and background information to familiarize your reviewers with the overall science and the focus of the project. But you want to spend most of your time on science justification. Break it down into specific questions that you might answer if you can. And again, thinking about the reasons that the GBT in particular is the best telescope to use for that particular science. Think a lot about your time requests. Again, you don't want to cut yourself short, but you also don't want to request more time than you need. And we have calculators that can help to determine how much time you will likely need to reach a given sensitivity. And also make sure you include all the information in your technical justification. There's there's text boxes asking specific questions. Fill those out properly. So these are general writing results and manual or tips. I don't think that any of this is particularly unique to the GBT. Write well, be concise, don't be overly verbose, get your point across with clearly, but in as little space as possible. Cite relevant literature, but don't just cite literature for the sake of having more citations. You want to point people to the things that are really important to understand your proposal and to provide support for it. Big one is to think about what might happen if you don't get the result that you're interested in. This is especially true if you're, say, trying to find like spectral lines, like an astrochemistry survey, and you don't necessarily know what you're going to find ahead of time, or searching for a new pulsar or doing a pulsar survey of some sort. If you can still extract meaningful science from a null result, maybe setting upper limits of some sort, mention that. That's a selling point. The refereeing panels, we'll talk about that in I think just a couple slides. They are broken down into science categories, but the categories are relatively broad. So you can't assume that the referees are going to be experts in your subdiscipline. So make sure that you provide, again, enough background information for someone who is certainly well-versed in the general area that you're submitting, but may not be an expert in that narrow range. Include everything that they need to understand the science justification. Do include figures. They do count against your page totals, but if in fact you're using a figure that is worth 1,000 words, then that's a good trade-off. Yep, read the proposal call in detail, make sure that you're up to date on all the instrumental capabilities. Definitely reach out to the observatory staff if you have questions, but please do that with enough time that we can provide you with the resources that you need. If you wait till the last minute, we'll do our best, but you may not be able to vet things as thoroughly as we could if we got a few weeks or something like that to go over any questions you might have. We have sensitivity calculators and mapping calculators that will help you plan your observations. Use those. And I'll show you those in a little bit here. Yeah, and the other things here are, I think, also fairly straightforward. So this is something I see a lot of people do. They put the abstract in the main body of the proposal. The referees and the technical reviewers will get the cover page of the proposal, which includes the abstract, along with the main justification. And we read all of it. So you don't have to repeat, save your space and dedicate that to an extra figure or filling out your science a little bit more. At the same time, don't feel like you have to reach the page limit. Most people, I think, need to in general, but no one ever complained because they got a short proposal that said everything it needed to say. Definitely don't go over the page limit, follow all the style guidelines. And yeah, try and excite your referees. We do have to read a lot of proposals, and you want yours to stand out. So as I said, the deadlines for proposals are August 1st and February 1st. This is true for GBO and NRAO, so we operate our proposal system jointly. The August deadline is for observing from February through July, so we consider that the A semester, which is within a given calendar year. And then the February deadline is for observing that will occur from August through January, and that's considered the B semester. You can submit joint proposals with a number of other facilities. This includes Hubble, Fermi, Chandra, Swift, and Sophia. So we have memoranda of understanding with these other facilities, so that if you need to request some GBT time and some Hubble time in order to complete your science, you can submit a request to Hubble and include GBT time in that. And then there's a joint review, but we've agreed to make a certain amount of GBT time available for Hubble projects if it's complementary science like that. So definitely take advantage of those types of memoranda of understanding. This certainly has been very beneficial for like Fermi and Chandra proposals, and we're hoping to see them for others as well. Maybe we do. I already mentioned filler time proposals.
Before we move off of proposals, there's a question about if there are proposals that are available to view somewhere.
So to my knowledge, we don't have any, I don't think we have any just generic proposals online. All the proposals are proprietary, so we do not make them public. You can see abstracts if they've been accepted, but that's it. So we can't just like release someone else's proposal. And I don't think that we have any examples like that available. But if you know someone who has submitted, you can definitely ask them. It's a principal investigator is certainly free to share their proposal if they want to.
And you can search those abstracts on the DSS system.
So there are 8 different scientific panels. These panels jointly review all the proposals that GBO and NRAO get. So that includes VLA and VLBA, not ALMA, that's a whole different thing. But VLA and VLBA and Green Bank. So they're judged across all of these. You will get a numerical weighted grade. It's a little bit backwards, but 0 is the best, 10 is the worst. So you want to see a low score, even though that might seem counterintuitive. Like I said here, that 200 hours is no longer relevant. I had the limits for large proposals on the other slide. The 4-page limit for regular proposals, 10-page limit for large proposals. Based upon your score, you will be placed into various groups. So as long as you fit within one of these groups, the exact ranking within the score, the numerical system is not really that important. All the proposals in group A receive equal priority, although it certainly is nice to know that you were a very highly ranked proposal. But A ranked proposals are the highest priority. They're active for 1 year. And we fully expect that you will get all of your time, barring some sort of extremely unforeseen circumstances. B-ranked proposals are 1 tier below that in terms of priority. They will only remain active for 1 semester, even if you asked for 2 semesters. So you would have to resubmit at the next proposal deadline if you needed to. But we still expect that they'll get most of their time, not guaranteed to get all of it. And then C is considered 1 semester, and that's filler time, so lowest priority. So you still may get some time, but it's kind of up in the air. N is just not accepted, so that's you'll get no time for those. So the technical justification, I'm going to show you what this form looks like, but you get unlimited space to fill out the technical justification. It's a form in the proposal submission tool. So you do not have to include it in the main body of your science justification, and you can tell us everything that you think that we need to know to be able to judge the technical feasibility of your project, but there are specific things that we ask. Yes, include overhead times. Depending upon the frequency at which you're observing, you will want to point and focus anywhere from every 30 minutes to 2 hours. At low frequencies, I would disagree with that. So for example, like pulsar observers, we really don't ever do pointing and focusing at like L band, prime focus receivers, even S band. At C band, definitely at the beginning though. Auto OOF every 1 to 2 hours. And then there is some interscan latency. So you need to think about slew times. Obviously, the further space on the sky your objects are, if you're going all over the place, the more time is going to be dedicated to that. There is just time for configuration balancing in between scans. You don't necessarily need to account for the 30 seconds of scan latency in between scans unless you're doing like hundreds of short scans all in a row, in which case that time will add up. If you're just doing a couple long observations, you don't need to really worry about the inter-scan time. Just real quick on overhead, I would say a minimum overhead, even if you're not doing any pointing and focusing, would be somewhere around 10 to 15 minutes. And that's just for a potential receiver change if the prime focus boom is out and an initial slew, maybe a test observation. So common mistakes, reaching the confusion limit. So doesn't matter how sensitive the telescope is, once you've reached the confusion limit and you can't distinguish one source from another, then unless you have some knowledge of what the emission looks like at higher resolution, you can't do much better than that. RFI, particularly at lower frequencies, but with satellite internet, car radars, this is going to become more and more of an issue, even at frequencies that have been relatively free of RFI. So we have RFI scans that you can look at to get some sense of what the environment is like. We have a table of known transmitters. All of this is available on our website. If you are trying to observe a spectral line where there is a lot of RFI, it's going to be difficult. If you're doing a continuum observation or a pulsar observation, you may have to lose a portion of your observing band due to RFI, but that doesn't mean that you still can't do your science. But you need to be aware of what the environment is like and have a plan for dealing with that. And we do ask about that specifically. So use the GBT sensitivity calculator. Not every project is necessarily making a time request based upon reaching a sensitivity. So for example, certain pulsar projects, I keep going back to that because it's my area of knowledge, may be observing, let's say like a binary pulsar. And the goal there is to observe a certain portion of the orbit because you want to measure the orbital parameters. You may not be limited necessarily by the brightness of the pulsar, but if that's the case, you should explain that. And if you do need to reach particular sensitivity, use the sensitivity calculator that we provide. It's sophisticated, it takes into account typical weather conditions that you might have, what atmospheric capacity is going to be, both that contributes to attenuation and to excess emission, known system temperatures, all of these types of things. So please use that if you're going to do your own calculation for some reason, which you may need to do sometimes. The calculator can't necessarily cover all potential uses of the telescope that people can come up with. Just make sure that you explain exactly what you're doing in a way that a technical reviewer can understand and recreate your result. Also, if you're going to do a mapping project, use the GBT mapping calculator. There are restrictions on the types of mapping strategies that we can do. We don't like to move the telescope, accelerate it through a lot of changes in direction over a short period of time. It leads to metal fatigue and would eventually lead to shortening the lifetime of the telescope or requiring additional maintenance in order to maintain the structure. And so there are limits to the types of mapping strategies that you can execute. The mapping calculator knows about those and will take that into account when helping you come up with an appropriate mapping strategy. So use that as well. As we go through the proposal submission tool, you're going to see a portion for sessions. So these are the actual time requests. If you need a particular LST range or particular fixed date and time, you would specify this here. You pair your sessions up with a particular instrument. And so this is what ultimately goes into the scheduling system when your project is considered for scheduling. Typical session durations for a project are between 3 and 6 hours. Those are not hard and fast by any means. We can get shorter sessions, particularly for projects that don't have a lot of overhead. So if you only have 10 minutes of overhead, then it might be worth your while to observe for only an hour or so. If you have 30 or 40 minutes of overhead, it's not really worth your while to observe for an hour. And so we consider that type of thing. We can also do longer sessions, maybe up to 8 hours, but that's kind of rare. Most projects will not require that. When you come up with a session, you will group your sources together. So think about grouping sources with a special right extension or a similar right extension and declinations in order to make that easier to schedule. When we schedule the telescope, unless you put in specific right or LST restrictions, the average right extension and declination of the sources in a group are used. So again, think about what sources will be up when during a session and plan that accordingly so you don't get into a situation where you're observing a number of sources spread across the sky, and because of the way you entered it, some of them may not be up during your entire session. We do try and check for that kind of thing when we do technical reviews, but if you have a very complicated observing plan, it can sometimes be a little bit difficult to catch those. And then there's some guidelines for how to maybe group your sources together that I won't go over. So yeah, so the GBT is oversubscribed depending upon the LST and frequency range by anywhere up to a factor of a few or more. So certainly if you can do your science by looking at objects that are outside of particularly oversubscribed ranges, particularly like the galactic center, that's great. And I've already mentioned fixed projects. These are becoming harder and harder to schedule. And so if you need fixed or windowed observations, so basically a specific date and time or observations within some, tolerance, like maybe like a few days of each other, that has to be ranked very highly in order for it to be considered for scheduling. So you really need to provide a strong justification for that. And I think this is my last slide. So I put some important websites here. These slides are all available online, so you don't have to write these down necessarily. But I linked to our webpage that has additional information for proposals, the portal for submitting proposals, which we'll look at now, the sensitivity calculator and the mapping calculator. So I do want to just kind of show you guys what these look like. I'm not going to go through them in tremendous detail, but I want everyone to just be familiar with it. Before I do that, are there any questions that I did not cover yet?
There was one comment that said, it's from Tapazi saying, I hope you discuss the sessions and resources. And right after she sent that, you talked about sessions. So
Yeah.
maybe just point that out whenever you get to the proposal.
Yeah.
And then there's another that says, does observing the same source using two different receivers amount to two different sessions?
You can pair those together, or you can put them in separately. And I think it kind of depends. If you need to observe them back to back, like let's say that you're looking for variability on timescales of a few days or a few hours, and so you really want to observe a source with two different receivers back to back, I would group those together inside one session and just make clear how you're splitting the time up between them. If it doesn't really matter the proximity and time, then you can split them into separate sessions, and that will make it a little bit easier to schedule.
Those are the only questions in there right now.
Okay. So I'm going to go to my.nrao.edu. The login name and password is different than your computing login and your DSS login. So make sure that you register for an account here if you don't already have one. I'm not going to go through that right now. So if you log in, you'll see something similar to this. I don't know that you'll see reviews. I see that because I do technical reviews. But if you click on proposals, you see all the proposals that I have been listed as a PI on. I'm going to go over here and say new proposal. And again, this is the portal for the NRAO and GBO telescopes. So if you were so inclined to be doing a VLBA or VLA or GMVA, then you could submit them through here as well. I'm going to click GBT and create. Okay, and so this is your cover page. Actually, I'm going to switch the desktop that I'm sharing. I have two screens, and the screen that I have the window on is not quite wide enough. Let me just switch that up. There, now I don't have to scroll over to the side to see all the buttons. So this is your cover page. If I were to click edit here, you have an opportunity to fill in your title, your abstract. You click your scientific category. Do think about this. This determines what scientific review panel is going to actually judge your proposal's scientific merit. So the list is here, and as you can see, there's a breakdown, broadly speaking, of the types of projects that might go into each panel to help guide your decision. You can choose whether or not you're submitting joint proposals with VLA, VLBA, and the other telescopes I mentioned. There's some information required there. There's a list here that you can choose from for the types of observing that you might do. So for example, pulsar, but let's say you're doing pulsar and you also want polarization information, you can click that. So this is, you click as many of these boxes as makes sense for you. Oops. If you have a student or are a student, PhD student with a dissertation, you can submit a dissertation research plan, although that gets attached on the author's page. This will get attached to the proposal, and it should explain how this project fits into your larger thesis work. We do give special consideration to student projects, so it can help potentially. We like to train up the next generation of students or astronomers. And then if you have related proposals, let's say that this is a continuation of an ongoing project or builds off an exploratory time proposal, you can enter that information here with the appropriate proposal codes. Authors, you add people, they do need to be registered in the system already, but there's a list that you can choose from. It's pretty straightforward. You can search by their first name, last name, these types of things, and then pull their information up. So I'm not going to go through that, but there's no limit to the number of authors you can add. Your science justification should be in PDF or plain text and would be submitted here. I'd say most people write their proposals in LaTeX and then make a PDF and submit it, but you can use a word processor if you want to and save it as a PDF. So this is the technical justification page. So you'll see that there are specific information that is requested. So for example, if you are requesting fixed or windowed observations, then you would enter that information in this first text box, as well as the reason why you are requesting that. If there's specific UTC dates and times, again, like let's say you want to observe a source when it's in conjunction, you should provide that information or at least a way of calculating it. This second box is where you justify your time request. So again, if this is sensitivity limited, then you can use the sensitivity calculator, which we will look at shortly. And you can actually just copy and paste the output of the sensitivity calculator directly into this text box, which is recommended to do. If you're not using the sensitivity calculator for some reason, you must provide a sufficient justification though. Don't just say, this is the amount of time that we're requesting, or tell us the back end that you want. You really do need to justify the time request in the context of reaching your scientific requirements. Again, if you're doing mapping, we recommend you just copy and paste the output of the mapping calculator, which I will show you shortly, into here. This box here is where you can talk about RFI. If you don't expect to face any problems with RFI, let's say you're observing in a protected band, great, you can mention that. If you do expect you're going to need to deal with RFI, just put something in there about how you're going to do that. And if it's as simple as, we will visually inspect our integrations and just flag any that appear to be contaminated by RFI, that's okay. But think about what fraction you might have to flag and whether or not you'll still be able to achieve your science goals. The next box is for overhead time. So this is where you can give an estimate of the time you need for receiver changes, slewing, pointing, focusing, auto oof, etc. And there's guides available that we're linked to help you plan for that. If you are submitting a joint proposal, then you can add additional technical information in this box. If you're doing something novel that has not been done before, it's kind of outside the typical use cases for the instruments that we have, that's fantastic. We encourage that, but you need to tell us about it so that we can judge the feasibility. And if you are doing something novel like that, it's strongly encouraged that you reach out to a support scientist and discuss that idea ahead of time. If you're doing pulsar observations, there's a little bit of extra information that we ask for. It's all pretty standard. And then if you have particular LST restrictions that are different than the standard recommendations for a given minimum elevation, you can list that here as well. All right, so for sources, this can be a little bit cumbersome. There's a lot of buttons you have to press. So you'll say my new source group, you'll give it a name and save it. And then this is a group. So now you have to add the individual sources to it. And you can have just one source in a group if you want to, but if you want to include many, then you can. You can include all the right ascension and declination information and any velocity information. You also can search Ned and Simbad. So let's say I want to observe 3C, 348. I'm pretty sure that's a real thing. Hit search. Hey, look at that. It fills in all the information for you. Isn't that wonderful? So take advantage of that. You don't have to necessarily type everything in by hand. Then make sure that you hit save. And I'm just going to create a second source group so we see what that looks like. So now I got two sources. Resources are where you actually ask for a particular receiver and backend combination. So again, it's done by groups. So I've created a group and now I have to add individual things to it. So we'll call this just one. We'll say I want L-band with Vegas and just going to do all the kind of standard things. Oh, it's in gigahertz. Look at that. How nice of it to remind me. And now I'll make another resource group and call this pulsar. And add. And I'll say I want Vegas pulsar. And just call this 2 and just say 340, 300 megahertz receiver, 300 megahertz bandwidth. And save. And then finally, we come to our sessions. So this is where you pair sources and resources together and tell us the time you actually want. So let's say I want 4 sessions. Separation of 0 days actually means that there's no restrictions. So there's no required minimum or maximum separation. So they can be scheduled whenever. Let's say I'm going to stick with the minimum elevation. And that I want 2 hours per session. I'm going to do my sources and I'm going to do resource group 1. It's a little bit annoying if you click calculate min-max LST, it doesn't do anything. You have to go back in, edit, and then calculate it. So it just doesn't know which source you've paired up with it until you save it. But now we'll calculate the min max LST based upon that minimum elevation and the average right ascension and declination of that source group, which for me was just one source, so that was easy. This one, I'll say I want 3 days minimum separation, and I want 5 observing sessions, and I want 3 hours each. And then I'll say I want pulsar and sources 2. And I'll say I want 5 degrees minimum elevation, because I'll just observe right down into the mountains. Don't even care. And now I can go back and that's everything. So now if I go back to the proposal submission page, you'll see that the time request has been filled in automatically. So you need to include your overhead time in your session durations. It's not added on for you. Double check that the total time request is indeed what you think it is, and that you didn't make an error when you were adding the number of sessions or the session duration. And when you're all ready, you can hit submit. It will validate the information, make sure you've entered everything that you needed, and then give you an option to submit. And then it goes into our system and is assigned a unique identifier.
Here's a question about sources. Do we need to add calibrator sources in the proposal?
You certainly can, but I don't typically do that. I just kind of usually pick them if I'm doing one. But yeah, it certainly can't hurt, particularly if it's going to impact when it can be scheduled, because you need a particular calibrator to be up.
And another question on a related topic about who can submit proposals. Are there country of origin restrictions for who can submit a GBT proposal, or for who can have an observer account on GBT computers?
So there's no restriction on who can submit a GBT proposal. There are restrictions right now on who can get an account. The reason is that there is certain export control information that can be accessed on our networks. It's basically like engineering documents for certain receivers. It's nothing classified, but there are certain US federal government restrictions that we have to follow, particularly as a federal facility. And so there are certain citizenship restrictions in terms of who can have access to that. But you can still be a PI on a proposal. Worst case scenario, we will do service observing for you and make alternative arrangements to access your data. I will say that we are also in the process of trying to better sequester that information on our computing system so that we have the proper permissions. The regulations tend to be changing from time to time, so that can make it difficult, and something that was compliant may not be going forward. So we are working hard to try and make it as easy as possible for anyone to use the GBT. Right now, we're kind of in a state of flux with that, but anyone can submit proposals, and we will make arrangements and work with you to get the data that you need.
Those are all the questions for right now.
Okay. Let me just show the sensitivity calculator briefly. It's pretty fully featured, so I'm not going to have time to go through every single potential detail, but there is a detailed user's guide that you can look at. You do have some options. You can choose observing time from desired sensitivity. So if you want to know, if you have a sensitivity you need to reach, you can figure out how much observing time it'll take. Or you can input the observing time that you plan on using and see what your sensitivity would be. You can get the sensitivity units in terms of flux density or different temperature scales. We'll just stick with flux density for now. And I said I want to know sensitivity from observing time. Let's do it. Let's do it this way. So let's say I want my 1 sigma sensitivity in Janskis, or sorry, millijanskis, to be 1e minus 3. So I want a microjansky sensitivity. I'm going to use the Vegas backend, I'm going to use it in spectral line mode at L band with a bandwidth of 11.72 megahertz. I will use in-band frequency switching. My source velocity, I'm just going to leave this all as the default, but you can enter that information here. I will use an internal model for the galactic background, and I'll just say that the right ascension is approximately 5 hours, and the declination is approximately 11 degrees. I'll say I can observe down to a minimum elevation of, say, 10 degrees. I'll leave all these as the default. And then my velocity resolution, I'll observe spectral lines. What's the typical velocity resolution one might need when observing H1? Kilometer per second?
Yeah, that's fine.
Okay.
That's going to be more than you need probably.
So then we'll click update results and let's see how much time it will take. Oh, that's a lot of seconds. I kind of had a suspicion that was going to be the case. So if you see scientific notation used in the time request, you probably are asking for a little bit too much, too low of a sensitivity. Let's just say 1 or too fine of a velocity resolution or something like that. That's still a lot of time.
Ryan, I think
yep.
that the sensitivity calculator now outputs everything in scientific notation.
Yeah, it does, doesn't it? So this is actually, well, this is still like 10 hours. So
yeah, but I think even if it's
still
like
a lot of time.
10 to the 1, it still does the, I've noticed it now still will do scientific notation no matter what.
Okay. But you can play around with it. 365 seconds seems like a much more reasonable amount of observing time.
Or not.
At any rate, this takes into account the amount of time that you're spending both on source and off source, but since we're doing in-band frequency switching, we can take advantage of always having our line of interest in band, and we can add that together. So when you do your technical justification, I would recommend that you simply copy and paste all of this output and put that directly into the technical justification section here. And then very quickly, the mapping calculator. So let's say I'm going to use Vegas, and I said I would use 11 megahertz bandwidth. I'm going to be doing frequency switching. I want noise diode on. I want hardware Doppler tracking. I'll do a rectangular region. We'll say 365 seconds. That's what I came up with in the sensitivity calculator. Let's say I want to map a 10 degree by 10 degree region. I will do critical sampling, so Nyquist sampling of the sky, so I can fully reconstruct my image. I'll oversample in the on-the-fly direction by a factor of 2. We'll stick with the recommended values there, and I'll stick with 4 integrations per switching period. And I hit submit. And again, this is the kind of stuff you just copy and paste into the sensitivity or the technical justification. But let's just see what it says. So it's going to use the sample time of 30 seconds. It's going to require 468 hours to map this, what I say, 10 degree by 10 degree region. That's the total time for the map. That's not all in one session, so that can be split up amongst multiple sessions. And that's, that's a large proposal, but that's not completely unreasonable. And it even gives you a handy set of commands to copy and paste directly into Astrid, so you don't have to figure out exactly what the observing duration is going to be, as well as the integration time and the switching period. And this is for if you're doing a right ascension map, so the direction you're moving in is right ascension. If you're doing a declination map, so the declination you're moving in is, or the direction you're moving in is declination, then this is the output. Mostly just impacts the commands you're using. Okay, I know I blew through those pretty quickly, but like I said, there's additional documentation. Your project friends can help you with any of that if you need it. And I think that I'm right up against my time limit. So are there any remaining general questions about anything related to proposals.
There's nothing else in the chat right now.
Okay.
Oh, there is one more. Are we going to write a proposal as part of this training?
You do not write a proposal as part of this training. However, you are strongly encouraged to think of a project and to submit a GBT proposal.
Could I ask a question?
Absolutely.
So if you have an idea for a proposal like mapping that I've never done before, are there specific people that I can contact at GPT to ask for technical help? Like I'll read through the manual or everything else, but if one still has an issue.
There are, so if you go here, I'll share my screen again. So if you go to our webpage and you hover over the Science tab, you will see GBO Scientific Staff, which takes you to this website here. And this has a list of all the people on the scientific staff, along with kind of their general areas of responsibility. So here I am, I'm scientist pulsars. Will does star formation, 20-meter Argus, and student programs. So you can gain some insight from this list of scientific staff in terms of who might be most appropriate to answer questions about a particular instrument. So for example, like Dave is kind of like one of our high frequency people. So he can answer things on Argus, K, Q-band, etc. Larry is our support scientist for KFPA. And then you can reach out to them. Their email addresses are listed here. But if you ever have a general question, you can just reach out to anyone on staff you've met now or to our help desk. You can submit a ticket and it'll get to the right person.
Thank you.
Any final questions for Ryan? If not, thank you very much. I'm going to just share my screen and leave it up for the next 25 minutes or so. Our final session today is just in a final session with your group for observation planning and data reduction. And then, of course, your second round of observations tonight, taking place sometime between 6 p.m. and 8 a.m. And I will put in the link again to your individual group workspaces in the chat. That will end all of the formal sections of this workshop, although we will be on hand tomorrow for 2 optional sessions if you would like to call back in for some more training. The first is an optional data reduction session between 1 and 3 p.m., again with the scientists that you've been working with for your observations. And the second is some supplemental Argus training that will be approximately 2 hours with some time to be announced. If you're interested in that one in particular, email Dave Freyer at that email address. Thank you all for your attention through all of these presentations over the past 2 days. And I will be in touch with you soon about any follow-up steps at the end of this workshop. But you should, in several days, if you go on to the DSS website, see yourself marked as remote trained. And so then if you're remote trained and your observations are enabled, you can expect to be scheduled hopefully soon. So we will take a break for the next 20 minutes or so, and then have our final hour of observation prep.